We are now going to solve a couple of quadratic equations by completing the square. Now, to be honest, this is actually not used that much, but this technique of completing the square, we're going to have to use that a couple times later on in this class, so it's good to just learn the principle now for when we need it later on. Normally with quadratic equations, most people either typically factor, use the square root property, or if they have to, use the quadratic equation. But let's go ahead and talk about how to solve a quadratic equation by completing the square. I've already given you the steps in class. I'm not going to write them again, but I will verbally mention them as I go through the problem. So let's look at this first example. X squared minus 8x plus 11 equals 0. All right, the first thing you have to do or make sure of is that there is no coefficient or no number in front of the squared term. Now the next problem we're going to work, we will have a coefficient. But for this one, since there's nothing in front of the x squared, we're okay there. Now the next thing you do is, the third term, or the term that's just simply a number, we're going to move that to the other side. So I'm going to subtract 11 from both sides, and you notice I sort of left a gap here where the 11 used to be, and you'll see in a minute why I did that. Now here's where we do what I call the special calculation, and that's where you take the coefficient or the number in front of the middle term, and I don't care about the sign, so I'm just going to, let me call it special calculation. I take that number in front of the middle term, I divide it by 2, and I square it. So 8 divided by 2 is 4, and if you square 4, that equals 16. Now what we do is we take that special calculation and I add it to both sides of the equation. And that's why I left this gap here. So I put the plus 16 here and the plus 16 there. Now the right hand side, you simply just add the two numbers. Now let's talk about what happens on the left hand side. The left hand side is now a trinomial, but it's not just an average ordinary trinomial. As it turns out, the left-hand side, when we use completing the square at this point, the left-hand side is going to be a trinomial. That's called a perfect square trinomial. A lot of times people label it PST. That special calculation is set up in such a way that when we're done with that, we are going to have a perfect square trinomial on the left-hand side. And a perfect square trinomial is very easy to factor and sort of has some special factoring. What you do is, the variable with the squared term, it's almost like you take the square root of it and put it inside parentheses. So the square root of x squared is just x. You take whatever the sign is in front of your middle term, and that goes here, and then you take the number term, and you take the square root of that, and that goes here, and you take that whole thing in parentheses, and you square it. So if I rewrite this so it's not as messy, I end up with x minus 4, that quantity squared, equals 5. So once again, The reason completing the square works is this special calculation will always cause the trinomial to be a perfect square trinomial. So it's always going to look something like this once it's factored. And at this point now we can use the square root property, which means we simply take the square root of both sides, because the square root of x minus 4 squared just equals x minus 4. And on the right hand side we now have to include our plus or minus. We have plus or minus square root of 5. And now if we want to solve for x, we simply add 4 to both sides. And now we have solved that quadratic equation. Now let me do a second example, which has a little bit of a twist to it. So that's 4x squared minus 12x minus 11 equals 0. All right, we're going to use completing the square to try and solve this quadratic equation. The first thing you have to be aware of is that 4 cannot be there. In order to use completing the square, we cannot have a number in front of the square term. So how do I get rid of that 4? What I can do is divide both sides by 4. And then I can divide the terms on the left one at a time. So 4x squared over 4 is just x squared. Negative 12x over 4 is negative 3x. Negative 11 over 4 is negative 11 over 4 equals 0. So now my squared term does not have a number in front of it. So now I go on and I need to move the number to the right hand side, so I'm going to add 11/4 to both sides. I'm going to leave my gap in here. And now if I do my special calculation, I take the number in front of the middle term, that 3, I divide it by 2, and then I square it. Turns out it's going to be 9/4. So I'm going to add 9/4 to both sides of the equation. The right hand side, at least I have same denominator, 11 plus 9, that's 20 over 4, which of course is 5. I'll write that in a minute. Now the left hand side, once again, this trinomial is a perfect square trinomial. And the way you factor a perfect square trinomial is you take the square root of x squared, which is x, you use the sign of the middle term, which is minus, and then you take the square root of your third term. The square root of 9/4 is 3/2. So you get x minus 3/2, and that whole quantity squared. So now we can take the square root property of both sides. This is actually 5 here. So I have x minus 3/2 equals plus or minus square root of 5. Then add 3/2 to both sides. X equals 3/2 plus or minus square root of 5. And now we have solved that quadratic equation. So once again, normally completing the square is not used to solve quadratic equations, but I wanted to show you the technique because later on in this class we are going to have to work some other problems out by completing the square.